Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your same module, that is the procedural programming module, and the topic is same, the C under the Linux, that is how to use the C under the Linux. Uh, in the last class we have discussed about the hardware interaction, that is how to interact with the hardware, how user interact with the hardware. New chapter we have started, that is chapter number 19, that is interaction with the hardware, right? So in the last class we have started with this chapter, and there are few topics in this, that is the hardware interactions, hardware interaction, DOS perspective, Windows perspective. Before this we have finished with chapter number 18, that is how to use the C under the Linux. This is C under the Linux. We have started with this chapter. In last class we have studied about the processes, like what is the process, how we can use the process, and what are the methods to use the process. So this says gone are the so let's start with the previous session, that is what we have covered in the last class. So this says gone are the days when only one job could be executed by the in memory at any given time. That is days are gone when only one task is executed, because it is a time, or it is a world of the multitasking, that is more than one task is operating at the same time, that is more than one task is executing at the same time simultaneously, that is known as the multitasking operating system. In Linux, each running task is known as a process, that is every running task is known as a process in the Linux, even though it may appear that several processes have been executed by the microprocessor simultaneously. That is, this paragraph says what we think, that more than one processes are executed at the same time, but no, that is not an issue, or that is not a real thing. But there are several processes that are executed in each running task, that is known as the process, that is done by dividing the time slot in a round robin method. That is, therefore each process gets the microprocessor attention in a round robin manner. Once the time slot allocated for a process expires, the operation that is currently executing is put on hold. That is, each and every individual process gets the operation, or gets the process, or gets the time slice for the process that expires the operation when it is currently executing is put on the hold, and the microprocessor now directs its attention to the next process. Therefore, at any given moment of time, if we take the snapshot of memory, only one process is executed by the microprocessor. So these lines explain you, and we have covered in the last class, that is how the round robin method works, how we can allocate the, or how memory allocate different processes, different tasks to different processes, and how different tasks are executed at different time. But we think that more than one task are executed at the same time, but no, that is not a case. So the switching of the process happens so fast that we get a false impression. That is, the switching of these processes is so fast, so we get an impression, false impression, that the process is executing several processes simultaneously. Then we have studied in the next paragraph, that is how the scheduling is done. That is, the scheduling of processes done by a program that is known as the scheduler. So scheduler is a program that is used to schedule the processes. So whenever there is a requirement for schedule the processes, that is done by the program that is known as scheduler, which is a important or the vital component of the Linux operating system. So that includes the system stack, application stack, and when the process again gets the time slot, these values are restored. The process, or this process of shifting over from one thread to another, is known as the context switch. That is, what is a context switch? That is switching from one thread to other, one process to another process, one task to another process, or one task to another task. That is known as the context switch. Kernel assigns each process running in memory a unique ID to differentiate it from the other running process. That is, it is the responsibility of the kernel to assign each process that is running in the memory a unique ID. That is, every process is executing, or every process is taken as a unique ID that is provided by the kernel in the operating system. This ID is known as the PID, or the process ID. This is a program that is used to print the PID of a program. That is how we can print the PID in a program. So how we can print the PID? By using the getPID function. So this getPID function is used to get the PID or to print the PID, that is the process ID. That is a unique ID that is available in the processes. So this says here getPID is a library function which returns the process ID of the calling process. So getPID is a library function that is available or which returns the process ID of the calling process. Hence, the kernel assigns a new ID to the process each time. This can be verified by executing the various programs, several programs at the same time. Then we have also discussed about the parent process and the child processes. That is, what is a parent process and what is a child processes. As we know, our running program is a process. That is, as we know, our running program, all the running programs is known as a process. From this process, we can create another process. So there is a parent-child relationship between the two processes. That is, we can assign the processes from the parent and the child relationship. The way to achieve this by using a function known as the fork function. So the fork function is used for the parent-child relationship. That is, there are two processes. Or what is the role of the fork function? That simply splits the running process into two processes. That is, there is one process that is running. That divides the single process, fork function, into two processes, one for the parent and one for the child. This is a program that shows how it can happen, how we can get the parent process and how we can get the child process. This is the header file that is used, that is hash include systypes.h. Then there is a int main, right? Then there is a printf. This is before forking. This is fork. As I told you, it divides the process into two processes. One is for parent, one is for child. So this is divides the process into two parts, and this is covered in the two parts, or this comes in two parts. That is after forking and after forking. This is before forking. Then this is the output that is given by this process. This is the output before forking. This is the first line. Then in the next line there is after forking. In the next line there is a after forking. Watch the output of the program. You can notice that all the statements after the fork function are executed twice. Once by the parent process and second time by the child process. In other words, fork has managed to split our process into two parts. This program is also used for the showing the relationship between the parent process and the child process. At such time, we would want to use the fork function to create a child process and then write the program in such a manner that will copy the parent process of the child process. So this is the program that shows how to copy the file and playing the animated GIF file. This is hash include systypes.h. There is a int main, that is the starting of the main. Then there is a PID, that is of integer type. Then uses the PID and stores the output of the function, fork function, into the PID. Then check the condition. If it is equals to 0, then simply printf in the child process, otherwise in the parent process. That is, if the fork function gives the output as a 0, that means it cannot divide the function into two parts, or it divides the function into two parts. It cannot know. It can divide the function into two parts, that is the child process and the parent process. So simply printf in the child process, otherwise in the parent process. As we know, fork function creates a child process and duplicates the code of the parent process in the child process. Therefore, the execution of the fork function continues in both the processes. Therefore, the duplication code inside the fork function is executed once, whereas the remaining code is executed in both the parent and the child process. This is what we have discussed in the last class. Now, This is the program that shows how to use the fork function or how to call the fork function to create a child process. In the child process, we will print the PID of the child and the parent. Whereas in the parent process, we will print the PID of the parent and the child. Here is the program that is given in the this one. There is a hash include ss types.h, that is a header file that is included in this one. There is a int main, that is the main function. Then int PID, that is the process ID, the same. This is PID equals to fork, that is if the fork function returns 0, so it is equals to the 0. Check the condition. If it is equals to 0, then simply printf child hello I am the child process. That is simply printf that hello I am the child process. Then this is used for printf for printing the PID of the child by using the function that is the getPID function. This is the getPID function, and this is as it is, it will print that is a child, there is a child's PID, there is a percentage %d. It is used for the getPID, that is whatever the unique ID of the process that is printed by using this line, right? Then in the next line it is child parent PID, that is what is the this is the child, and what is the ID of the parent, that is get by the get PPID. One is the get PID, that is for the child process. One is the get PPID, that is a get parent person process ID, that is a get PPID. So for parent it is used as a get PPID. Otherwise, if it is not equals to 0, that is it is equals to 0, this whole will be printed. If it is not equals to 0, that is else part, simply printf parent, that is I am the parent process, that is simply printf that I am the parent process. Then in the next line it is printed the, or it will print the parent ID, that is also printed by using the get ID. So get ID is a function that is used for printing the parent ID. Then there is a parent child's PID, that is a child PID that is given by the only the PID. So this is simply a PID, this is the get PID, and this is used for the parent and the parent ID only. This is used for the child PID. Then there is a closing of this else part, and this is the closing of this int main, right? So I'm repeating this example. First of all, the header file will use, then there is the int main, then there is a int PID, that is a PID, that is the process ID. Then check the condition, store the output of the fork function into the PID. Then check the condition. If it is equals to 0, that means fork function if returns the value as a 0, then simply printf these three statements. And in these three statements, one function is used for getting the process ID, one is the get PID and one is the get PPID. Otherwise, if it is not the case, that is a fork function does not return the 0, then simply printf parent I am the parent process, and the parent ID, that is a get PID, parent child, that is a PID. Then there is a closing of the curly braces. This is the closing of the int main. This is the output. This is child. First of all, there is a child. Hello, I am the child process. This is hello, I am the child process. Then child's PID. This is a child's PID. Then what is the ID that is given? That is a 4706. Then child parent's ID, that is the parent's PID. This is the parent's PID. What is the ID of this one? That is the 4705. Else, if it is not the case, hello, I am the parent process. Parent PID, this is the 4705. This is the 4706. This says in addition to the get PID, there is another related function that we have used in the get PPID. As a name advice, it returns the PID of the parents of the calling process. That is, as the name advice or as the name suggests, this function returns the PID, that is the process ID of the parent of the calling process, that is given by the calling process. You can tally the PID from the output and convince yourself that you have understood the fork function well. That is, you can tally the PID from the output. A lot of things that follow uses the fork function. So make sure that you understand it thoroughly. Note that even Linux internally uses fork function to create new child processes. That is, Linux also uses internally the fork function for the new child process that is given by the fork function. Therefore, thus there is an inverted tree like structure of all the processes running in the memory. So this is a fork function that Linux automatically uses internally, that divides the process into two parts. One is the child process, one is the parent process. The father of all these processes is the process known as the init. So who is known as the father of all these processes? That is known as the init. That is also a process, that is the init process, that is the initialization process. If we want to get a list of all the running processes in memory, we can do so using the ps command as shown below. So if we want to get a list of all the processes that is available in the Linux, that simply prints, or they simply use, or we can simply print by using the psa. So ps is a command, Linux command, that is used to get the each and every processes, that is used to get, that is what is the list of the all the running processes in the memory. That is, what are the types of running processes that is available in memory. Here the switch A indicates that we want to list all the running processes. So this indicates that this is we want that listing of all the running processes. Then next topic is, so now let's move to the next topic, that is more processes. We have discussed about the processes, about the fork function, how we can use the fork function, how we can list all the running processes. Now the next topic is more processes, that is a more detailed explanation about the processes. This says, suppose we want to execute a program on the disk as a part of the child process. Suppose my requirement is to execute a program on the disk as a part of the child process. For this, first we should create a child process using the fork function. That is, first of all we should create a child process, that is done by using the fork function, and then from within the child process we should call an exec function to execute the program on the disk. That is, suppose my requirement is to, or we want to execute a program that is available on the disk. For this purpose we must create, or first of all we create a child process using the fork function. Then from within the child process we should call an exec function, that is the executable function to execute the program on the disk as a part of the child process. Note that there is a family of exec library functions. So this is the family of the executable library functions. That is, there are so many executable library functions that is available that does the same job but with a minor variation. That is, role of the every executable library function is same but with different, or but with little variations. For example, execl, that is the executable cl, permits us to pass a list of command line arguments, that is, as the name advice, executable command line arguments, that is the execl, to the program that is to be executed. Then execv, that does the same job at the execl, but that the what is the difference? That the command line argument can be passed to it in the form of array of pointers to the string. There also exist other variations like execle and the execvp, that is available with the executable file. Let us now see a program that uses execl to run a new program in the child process. One is the hash include uni istdh, that is a uni stdh, that is available, that is a hash include. Then there is a int main, that is a main function. This is the PID, that is a process ID. Then again check the condition, PID equals to 4, that is check the condition that if it is equals to the fork function. Then no, check the condition, simply passes the variable of the, passes the argument of this one, that is a return type, that is simply passes the output of the fork function into the PID, right? Then check the condition, if it is equals to 0, that is if the PID, that is the process ID, is equals to 0, then simply printf, or simply use the function that is the executable command line argument, that is the execl function, simply uses that one. Then printf child after execution, that is a child after the execution, after executing the statement. Else printf parent process, that is if it is equals to 0, that means fork creates the function, or fork uses the function, or fork splits up into two parts, that is the child and the parent. They simply call the executable command line argument, then simply a printf, that is after exec function. Otherwise it is not equals to 0, then simply printf parent process. After forking a child process, we have called the executable command line function, that is after using a child process, we have called the function, we have used the function, that is the executable cl function. This function accepts a variable number of arguments. So this is a function that accepts n number of arguments. These are n number of arguments that is available in this one. The first parameter to exe is the absolute path of the program to be executed. That is this is the absolute program that is available, that we can use in the command line arguments, right? So there is a function that is used, that is the executable cl function, that is used for the executable command line arguments. This function accepts a variable number of arguments. The first parameter is the absolute path of the program to be executed. This is the first argument, that is in one double quotes, this is in the second double quote, this is in third double quote, this is in fourth. That is 1, 2, 3, 4, 4 arguments. This is the absolute part that is available, that shows where the program is to be executed. The remaining parameter describes a command line argument. That is only first part, or the first parameter that is available, that represents the absolute path. Otherwise the remaining arguments, remaining parameter describes the command line arguments from the program to be executed. The last parameter is an end of the argument marker, which must always be null. That is the last one must always be the null one. Therefore in our case we have called upon the executable cl function, that is a command line function, to execute the ls program as shown below. So we have used the ls with this one. This is bin ls, that is used for the listing, that is ls al etc. As a result of this, all the content of the etc directory, that is every content of the etc directory that is available on the screen, that is it results each and every file, each and every directory, because in Linux every file, every input output device, that is everything is known as the file or the directory. So it shows that etc directory is available, the content of the etc directory is listing on the screen, that is done by the ls. Note that the printf below the call to execl function is not executed, that is the exe function is not executed over here. This is because the exec family function overrides the image of the calling process, that overrides the image of the calling process that is available in this one. So with the code and the data of the program that is to be executed. In our case, the child process memory was overwritten by the code and data of the ls program. So in this case it is written, or it is overwritten by the code and data of the ls program. Hence the call to printf does not or did not materialize. It would make little sense in calling executable cl before fork. That is, it makes sense in calling the executable command line argument before the fork function. Therefore, or this is because a child process would not get execute or created, and executable cl would simply override the main process itself. That is, it will not execute the memory, it will not execute, instead this will override the main process itself. As a result, no statement beyond the call to executable cl would ever get executed. Therefore, this usually go hand in hand. That is, they are used hand by hand, that is side by side, that is a execl, that is a executable command line function, as well as the fork function. Now, next part is here zombies and offense. That is, what is zombies and what is offense. These are the various parts, these are the various categories, how we can use the orphans and the jargons or orphans. So these are the additional processes that is available. One is the executable CL function, that is also a function. One is the EXE executable CLE function. One is the executable CVP function. So these are the various processes that is available under Linux. Now let's move to the next one, that is a zombies and the offense. That is, what is zombies and what is offense in the Linux. We know that the PSA command lists all the running processes that is run by the PSA command that runs each and every process. But from where does the PS command get this information? That is how it will list each and everything into the on the screen that is done by the PS command, but from where it will execute or from where it will list the running processes. Well, Linux maintains a table containing information about all the processes. So, and this is the answer. How this can be achieved, how we can achieve each and everything, how we can or we are able to list each and everything that is available or that is done by the listing. This table is known as the process table. So Linux maintains a table containing information about all the processes. That table is known as the process table. Apart from other information, the process table contains an entry of the exit code. There is an entry of exit code that is available of the process. This integer value indicates the reason why the process was terminated. So this indicates the reason, or this tells the reason why this process gets terminated. Even though the process comes to an end, its entry would remain in the process table until such time that the parent of the terminated process queries the exit process or exit code. So even though the process comes to an end, its entry would remain in the process table until such time that the parent of the terminated process queries the exit code. This act of querying, that is, this act of querying deletes the entry of the terminated process from the process table. That is this act, or this is the procedure of querying that deletes the entry of the terminated process from the process table and returns the exit code to the parent that raised the query. So there is a process table that is available that contains each and every information that Linux maintain about all the processes. This integer value indicates the reason why the process was terminated. So when we fork a new child process and the parent and the child continue to execute, there are two possibilities. So when we use a fork function, or when we fork a new child process, that is when we use when we fork a new child that is available and the parent and the child continue to execute, there are two possibilities that is available. Now, what are the two possibilities? That is either the child process ends first or the parent process ends first. That is, either the child process comes to an end or either the parent process comes to an end. Now let us discuss these possibilities. So what are the possibilities that I will discuss in the next class. So let's stop over here only the theory part. Now let's move to the practical part, because in the last two classes we have executed only two programs. So it is better to execute the more program about the functions. So let's move to the practical part today. So let's move to the practical part. So today I'm going to continue with the practical part of the function, that is how to use the function under the Linux, or how to use the function simply, not in Linux, but for the time being it is how to use the functions in the C language. So in the last class we have studied about the functions, that is how to use the user defined functions. Now it's a time to today I'm going to continue with the same functions topic, but with the new concept, that is a local and the global variable. That is how to use the local variable and how to use the global variables. So this is the function. This is the local variable, example of local variable. that is hash include stdir.h. This is the header file. This is the second header file. Then there is a void main. Then there is a curly braces. Now this is the same, that is the hash include standard input output file, that is the standard input output.h. One is common input output.h, that is a conio.h. Then there is a void main, that is the main entry gate. Then there is a variable declaration, for example b equals to 10 and c equals to 5. This is the example, right? Then there is a clear screen for clearing the screen. Then there is a printf for printing purpose, that is in main simply write, that is in main function comma b equals to percentage d and c equals to percentage d. That is done by using b comma c. Then simply uses or call the function, that is a fun function. Then simply define the fun function, that is available. That is we have declared more two variables, that is for example 20 and 30. This is my example. This is 20 and this is 30. This is 20 value and this is 30 value, right? Then simply uses the printf statement for printing purpose, that is in fun. This is in fun. We have used in different lines, so this is /n, this is /n, that is in fun, that is available, that is in fun. This is a function, that is b equals to percentage d, c equals to percentage d. Then there is a comma, then there is a values of the b and c. Then there is a closing of this one, that is a fun function. Then this is the closing of this one. Now we have put get ch over here only because this is the void main function. Now if I compile this code, there is only one error. Should function have a prototype, that is this must have a prototype. Why? Because we have not saved with the C language, that is this is local variable, like this is the local and there is a variable. This is the local variable. This is .cpp, no, this is .c. Now if I compile this code, there is no error, that is there is only one warning, that is a function return any values. Now if I execute this code, the in main function the b equals to 10, c equals to 5, in fun function b equals to 20, c equals to 30. Now let us understand what is the use of the local variable. As the name advises, local variable, that means these variables are defined within the body of the function or the block, that is it is defined within the body of the function. For example, there is a void main function. We have defined two variables, that is b equals to 10 and c equals to 5. So these are the local variable, that is local to the function or local to the block or local to the void main function. So any variable that is defined within the body of the function or under the block, that is known as the local variable. The variable that is defined is local to that function or block only. So that is defined is only to the block or only to the function that is available in this one. Other functions cannot access the block. That is if I want that 10 and the 5 values are accessed by anyone. No, that is not possible. That is not available in the local variables. So other functions cannot access these variables. It can only access within the block, or it can only access by the function that is available within that block, that is within that curly braces only. The compiler shows error in case other functions try to access these variables. That means these variables are compatible, or these variables are available only in this function, only in only in that block in which it is defined. Otherwise, it is not available, right? So this is a local variable. Now, let's understand the program. That is a hash include stdr.h and the hash includes conio.h. So there are two header files that is available. One is the standard input output.h, one is the common input output.h. Then there is a void main, that is a main function that is available. Then there is a curly braces that start, then b equals to 10 and c equals to 5. There are two variables that is declared. One is the 10, one is the 5. That is, b has given a value that is 10 and c is given a value that is 5. Then there is a clear screen for clearing the screen. Then there is a printf statement for printing purpose. This says in main, that is in main function, b equals to %d, that is b has some value, and in main c has some value that is defined as a b and the c. Then there is a fun function. This is the function calling. So there is a function calling, that is a fun function. As soon as the cursor places over here, it moves directly the cursor into this one. That is, if the cursor is available over here, this moves the cursor to this one. So whenever this is the calling function, so the cursor directly jump to the definition of the function. This is the definition of the function. So this directly jump to this one, right? Now this is b equals to 20 and c equals to 30. That means it cannot overwrite the value of the b and c. This simply uses printf, that is in fun b equals to %d and in fun c equals to %d. That is, we divide these values into two parts. That is for showing that these are local variable. That means in void main function these values are not accessible. In the same way, in fun function these values are not accessible. Why? Because these values are local to this block only, and these values are local to this block only. That is 20 and 30 are local to fun function, 10 and the 5 is local to the main function. So this is the way how local functions are defined. So what is the output? First of all, 10 and 5 will be displayed, then 20 and 30 will be displayed. That is, this statement first of all it will display, then this statement will display. Whenever there is a closing braces, it is available over here, then it will be printed. And then there is a get ch for simply printing the output on the screen. Now if I execute this code, in main function b equals to 10, c equals to 5. In the same way, in fun function b equals to 20, c equals to 30. So this is the way how it is defined. Now let's move to the next topic, next part, next variable, that is the global variable. One is the local, one is the global variable. These are the most important part of the functions. That is the local variables and the global variables. Now let's see what is the usage of the global variables. So global variables, as the name advises, local means local to the block. Global means that is acceptable or that is defined outside the main function. That must condition is that is not defined within the main function, but that is defined outside the main function, and it can be accessible by anyone, any person, any program, any function, anyone. Why? Because this is a global variable, that is globally it is used and it is defined before the main function. So if it is defined before the main function, so how is that possible to access these values? So that is provided by the global variable. That is, we can access each and every value that is defined beyond the main function. That is known as the global variables. So understand the difference. Local variables are limited to the block in which it is defined, and global variables are accessible by anyone, and the condition is that it is defined before the main function. So now let's see the program that is able to write that what is the example of the local variable and the global variable. Example of global variable. Now let's start. That is hash include stdio.h, then hash include conio.h. Then there is a void main function, then there is a closing curly braces start. Now so before using the void main function, let's define the global variable that I forgot. That is int, the same example, that is b equals to 10 and c equals to 5, the same example that we have discussed right now. Then in printf, simply uses the clear screen first of all and simply printf the same line, that is the printf the values, that is printf in main function b equals to percentage c d, then c equals to percentage d, then there is a b, then there is a c, then simply uses the fun function, then there is a b++ and the c++, for example, so that you can understand how it will be used by this function. Then simply printf the values after this one, that is simply printf, that is again in main, that is just it is going again in main function, b equals to percentage t, c equals to percentage d, bc, that is available over here, that is we have to use that double quotes over here. Now this is not C++, this is minus minus, so that you can understand. Then simply closes this one using the getch and define the function of the fun function. Now what is the definition of the fun function, that is available over here. Now let's see. First of all, let's see this one. First of all, I have to save this one, that is a global. Now let's start with the same program, that is the usage of the global variable, that is how to use the global variables. That is a program that is available. We have studied about the local variable, that is how to use the local variables. Now it is a time to use the global variables. There is a program that is for global variables, that is a global variable we have open. So in fun, we have defined one more function, or we have used simply b++, because this is accessible by the function only. This is c minus minus, they simply use printf, then simply used in fun, that is in fun, what is the output, that is in fun function, b equals to percentage d and c equals to percentage d, b comma c, then it is used, that is b and c, then there is a closing of this curly brace. Now if I compile this code, there is zero error, but there is a warning, that is must return any value. If I compile this code, in main there is a b, that is a 10 and the 5, in fun it is the 11 and the 4, again in main it is 12 and the 3. So it simply shows how to use the global variables in this one. That is how to use global variables. The same variable is accessible by any number of n number of argument, whether maybe in the same block, whether it may be a different block. We can use, or these global variables are used in the same function again and again. So now let's try run this program. These are the header file that is used, that is hash include stdi.h, hash include conio.h. That is a standard input output, and that is a common input output. Then there is a function variable that is declared before the main function. So how do I know these are the global variables? So the variables that is defined outside the main function, that is known as the global variables, and the variables that is defined inside the main function, that is over here before the clear screen, that is known as the local variables. This is known as the global variables because it is defined before the main function. So this is int b equals to 10, c equals to 5. There is a void main function. Then this is the curly braces. This is the clear screen for clearing the screen. Then this is the printf for printing purpose. That is, it is printed like this one. That is in main function, b equals to %d, c equals to %d. That is, we are in main function. What is the value of b? That is 10. What is the value of c? That is 5. So the output is 10 and the 5. That is the first output, right? Then simply call the fun function. Now this is important. When the cursor is over here, it moves to this one. It moves to this function. This is the function calling, and this is the function definition. Whenever there is a function calling, the cursor directly moves to the function definition. This is fun fun function. Now there is a b++. That is the b++. That means the increment of the b. That is the value of b is incremented. Then c minus minus. That is the value of c is decremented. So when the value of b is incremented, that is b++. That is the 11. And value of c is decremented, that is 4. So this becomes 11 and 4. This is 11 and this is 4. So the output of fun function is returned from this curly braces, closing curly braces, and the output come over here is 11 and the 4. So when I compile this one, the output is 11 and 4. b equals to 11, c equals to 4. Then there is a b++ and the c minus minus. That is, again there is a b++ and again there is a c minus minus. This is b++, that is incrementing the values of the b, or incrementing the value of b. So now b value becomes 11 plus 1 is 12. Why it is b is 11? Because here it is incremented once. Now it is incremented twice, and these two variables, that is b and c, are shared by each and every function simultaneously. So once the value is incremented, that means that becomes fixed, or that values become fixed. So this is b++, that is 11 plus 1 is 12. So the b value is 12. c minus minus, that is 4 minus 1 is 3. So now the value of b is 12 and the c value is 3. Then there is a printf. Again in main, this will print it and prints the value of b and c, that is a 12 and the 3. Then there is a get ch for printing on the screen. So the last output is 12 and the 3. So this simply shows that these two variables, that is the b and c, are the global variable that must be accessed, or that can be accessed by each and every function. So if there is any value that is incremented, that impact on the other function. If there is a value that is decremented, that impact on the other function. So there is a b++, there is a c minus minus. This is the void main function. This is the global variable function. So how can I define what is the global variable and what is the local variable? So local variables are defined within the body, or within the body of the function or the block, right? And these are available inside the curly braces. And global variables are defined outside the main function. That is, whenever the variables are declared outside the main function, that is known as the global variables. So we have discussed two examples. One is for local variable, one is for global variables, right? Now let's see how we can, or how there is a return statement that executes. That is how we can return the statements. That is how we can use the return statement in this one. Suppose I want to return the value over here, that is return. Simply use return. That is simply use return. If I compile this code, the same output is come. So if there is, I want that there is a return statement, I can write it, otherwise I cannot write it. So there is no impact, but yeah, there is an impact whenever we have to store the values in some variable, and then we can use the return statement over here, right? So now let's move to the next part. There is a next program, that is write a program to display user defined functions. Write a program to display message using user defined function. Using user defined functions, that is a user defined functions. So first of all, start with the header files, that is a hash include stdi.h and the hash include conio.h. Then there is a hash include conio.h. Now there is a void main function, that is a void main. Now there is a curly braces that is available for starting the function. Then simply use the function as a void message. Then there is simply use the function as a message, that is also the function calling, that is a message. Then there is a closing curly braces over here. Then simply defines the message, that is definition of the message, that is a user defined function, that is a void message. That is a void message. This is the function definition, that we can how we can declare the function. Then simply use puts for printing the message, that is have a nice day, for example. Then simply closing the curly braces. Now if I compile this code, there is zero error, there is success. If I execute this code, this will execute, but the output is not coming because we have not used the getch over here. So we have to use the getch over here. Now if I compile this code, yeah, no, what is the problem? If I again compile this code, there is a success. If I again execute this code, yeah, this is given, have a nice day, have a nice day, 3 times. Because why 3 times? Because we have not used the clear screen over here. So we have to use the clear screen over here for clearing the screen. So if I execute this code again, have a nice day will print, right? This is a program that is able to display the message or prints the message using user defined function, that is available, that is a user defined function. So now let's understand the program, what is the program, and now let's try run this program. First of all, 2 header files are used, that is the hash include stdi.h and the hash includes conio.h. So these are the 2 header files that is used. Then there is a void main function for entry gate, that is a void main. Then there is a clear screen for clearing the screen. Then there is a message calling, that is a message calling, that is a void message. So void is a return type of the message, that is we have defined the message, or we have called the message, that is a void message. That is we have given the return type also along with the message. Now uh, let's see if I does not give this one. Now if I compile this code, there is an error. What is the error? The function message should have a return type. That is, it must have a return type over here. Now if I not using this one, and if I'm using this one, now let's see, this will not print anything. Why? Because the message is not arrived anywhere. So we have to define the message, we have to define the user defined function, or we have to make the user defined function. So first of all, the void message is used, that is, we have also given the return type, that is of void. Then there is a message function that is available, that is a message function. So whenever there is a message function is used, the cursor directly moves to this one, that is a void message. This is again the return type, that is a message. And this we have to print the line, we have to print the content, that is have a nice day. So this is the content that is printed using puts. So puts is a function that is used for printing purpose, that is a puts, that is have a nice day. This will print after the brackets inside the bracket, that is have a nice day. So this is how it will be printed. So remember, gets is used in place of the scanf and puts is used in place of the printf. So these are the this is an example, this is a program that shows how to display the message using the user defined functions, right? So these are the content of the void main. This is the definition of the message, that is a void message. So if I save this one, we can define, that is, that simply uses the message, that is a function. Now let us understand one more concept, that is how to use or how to define the values, or how to define the user defined function as a new one. That is again the category of the this one, that is hash include stdio.h hash include conio.h. Then there is a void main, then there is a curly braces, then there is a void, there are functions that is available, that is void a, b, c. So these are the three functions that is available. Now we have to define the function, that is a, then b, then c. So then closes this one, that is, we have called the function like this one. Then there is a void, that is the a function, that simply used for printf, that is a printf, that is simply /n, then simply use the void main, next one, that is a void b, then simply use the printf, then /n, then next line will be printed, that is a b, then there is a closing of this one, then there is a void c, then again there is a closing of this one, that is simply prints the values of this one, that is /n, that is the c will be printed. Then this will also closed. Yeah, 3 we have defined, then simply prints the values of this one, that is a /n/t/t. If I have to print in the next line. Now if I compile this code, there is a success. If I execute this code, there is no output. Why? Because we have not used the getch over here. Now if I define the getch over here, ABC, ABC, this will print 2 times. Why? Because first of all it is defined, then this is defined. So this is ABC, ABC, 2 times it will be printed. That is, it is a program that is able to print that how it will be used, how it will print the values. Now again if I compile this code, ABC, ABC, because why? We have not used the clear screen over here. That's why it is coming multiple times. Now if I compile this code, there is a ABC 3 value or 3 alphabet that is printed. So this is a program that is able to display the characters, that is the alphabets, using the function. That is simply use the functions that is able to display the characters like A, B, C, D. So there is a clear screen. Now let's try run the program. That is how to use the program. There are two header files, that is a hash include stdi.h and the hash includes conio.h, right? The two common files, that is standard input output and the common input output. Then uses the void main function for the main entry gate. Then there is a clear screen for clearing the screen, that is clr scr. Then there is a function, that is a void a b c. There are three functions that is available. One is a, one is b, one is c. Now declare the above part shows that the return type is void of the a, b and the c. Then there is a function calling, that is a function. There is a function calling, that is a b function. There is a function calling, that is a c function. So three functions are called over here. Then there is a getch, that is the getch is used for showing the output. Whenever cursor moves to this one, this directly moves to this one. This is the definition of the a function. Whenever cursor moves to this one, this is the definition of the this function, that is the b. Then void c, that is this is the definition of the this one, that is the printf c, that will simply print the c. So first of all, a will print, then b will print, then c will print by using this function. So first of all, this will print the a, this will print the b, this will print the c. So this program simply shows how to display the alphabets, characters using the user defined function that is available in the function. That is the way how it will be used. So right, so we have to give the name of the program. And we have to save this file, that is function 1. This is already available, this says that is already available, so we have to define function _1. This is already defined, so we have to give the another name, that is a func, right? This is a function. Now so that's all for today's session. This is the practical approach for the today's session. In the next class, that is in the tomorrow's class, I will be starting with your next topic. That is the next topic. What is the next topic? That is this is the theoretical topic, that is how we can or what are the two possible conditions in which the parent and the child process is executed. So now let's stop over here only, and we will meet on the tomorrow, that is with the theory as well as the practical part. That's all for today's session. Thank you so much. Now again I'm saying the same thing. If there is any doubt, then please collect the doubt and mail to me or mail to you, so that you cannot forget the doubts. So either you can mail to me and I can for sure simply solve your doubts individually whenever I come to the class. I will come to the class on the Monday, that is of 2nd of Feb. So don't worry, I will come to the class on 2nd of Feb, that is on Monday. Only 2 or 3 days are left. So I will take your doubts each and every one individually. So that's all. Thanks a lot. Bye bye everyone.